Problems number 14 and 15. The following information applies to questions 14 and 15. An object starting from rest can roll without slipping down an incline. Problem number 14. Which of the following four objects, each with mass m and radius r, would have the largest acceleration down the incline? Solution for problem 14. Here we have to check the object with the minimum of moment of inertia, because in that case the translational kinetic energy will be highest, the final speed will be highest. It means that acceleration will be highest. And in our case, uniform solid sphere has moment of inertia 2/5 mr square, uniform solid disk 1/2, a hollow spherical shell 2/3, a hoop just 1 mr square. So, and E, it's not correct because they don't have the same moment of inertia. Means that only a uniform solid sphere will have largest acceleration. So correct answer is A, and this is the solution for problem number 14. Problem number 15. Which of the following four objects, each of a uniform solid sphere released from rest, would have the largest speed after the center of mass has moved through a vertical distance h? In all four cases we have sphere, and it doesn't matter what is the mass and the radius. The matter is what is the formula for moment of inertia, and in each case that will be the same moment of inertia. It means that the final speed will be the same after all, and that's answer E, and this is solution for problem number 15. Problem number 16. A rod moves freely between the horizontal floor and the slanted wall. When the end in contact with the floor is moving at the speed v, what is the speed of the end in the contact with the wall? Solution for problem number 16. Each motion for solid body we can split by rotational and translational motion. Here we can represent velocities for two ends of this rod. Let's v be the vector of velocity for left end of this rod, and u will be vector of velocity for right end of this rod. So we can split these two vectors by translational and rotational motion of this rod. We are not interested now in rotational motion, but for translational motion we have to make projection of these two vectors on instantaneous direction of this rod. If we take this projection for v and for u, these two projections they have to be equal to each other to save the length of this rod. And this is why we have this equation. We have v cosine theta, which is the projection of this vector v on the direction of this rod, equal to u multiplied by cosine alpha minus theta, which is a projection of this vector u on the same direction. And from here we can find immediately what is u. So u equal this expression, and this is answer D. That was a solution for problem number 16. Problem number 17. An object is thrown directly downward from the top of 180-meter tall building. It takes 1 second for the object to fall the last 60 meters. With what initial downward speed was the object thrown from the roof? Solution for problem number 17. Here we can use average speed for the last part of this way. And we have average speed equal to 60 meters over 1 second. which is 60 meters per second. Now we can find what is the speed of this object right before it fell to the ground, because average speed equal to speed right in the middle of this 1 second. It means that after that this object traveled for half second and it got additional speed g multiplied by half second. So we have final speed is v average plus g multiplied by half seconds, which is 65 meters per second. And now to find what is initial speed, we can use this formula. So we have initial v0 square equal v final square minus 2gh, which is 625. It means that v0 equal 25 meters per second, and this is answer B. And this is the solution for problem number 17.